Okay, so welcome to the reactive dice experiment. Now, here we've got lots of little dice with one side coloured. The other sides of the dice are not coloured. Okay, now these dice are not actually radioactive, but what they do is they're representing radioactive nuclei, unstable nuclei, that I'm throwing this one, and when it lands colour side up, it has decayed. Now there's always a certain chance each second that the nucleus is going to decay, give out radiation. Oh, and there, this one just decayed, and because it's decayed, it's giving out radiation, it's turned into a stable nuclei. So I then take it away from all the others, and all these dice here represent a massive sample of nuclei, which is what we would have in just a few, maybe a few micrograms of radioactive, a sample of radioactive isotope. And each nuclei, when I throw it, and I throw all of these, each single one has a chance, a 1 in 6 chance of landing coloured side up, so 1 in 6 chance of decaying and giving out radiation. Once it's decayed, then I take them out of the mix. But as you see, this experiment takes a really long time, a lot of patience and a lot of counting. So in my tray, I've just thrown all these dice, and the ones that are colour side up in that first throw have decayed, because there's a 1 in 6 chance. So what I do is I'm going to pick all these coloured dice out into a separate cup, and then I'm going to count them to see how many decayed on that first throw, how many colour side up in the bottom of the tray. And once they landed colour side up and I've counted them, I take them out of my sample of radioactive dice, and I'll write down on the board that I'm using here how many of these dice have decayed. Now, to stop this YouTube video being like an hour long, because it took an hour, we're going to increase the velocity a little bit.
Isn't it lucky that I'm going to
20 times. So I'm going 20 times faster than I should be.
Después.
In a moment.
Y cambia la velocidad.
Ha! Because you don't want to watch me picking these dice out one by one for a whole hour.
No,
so we're going to condense that hour it took me into just a couple of minutes now. And what you need to write down is, for each throw, how many dice landed colour side up. And once we've written this down in a table, throw number 1, so many dice. Throw number 2, so many dice. We will, once we've written this down in a table, we'll draw a graph, plot a graph, and we'll make some calculations. Okay, so this is 20 times faster than real life. Pick out all these that have landed colour side up. Then I'm going to count them. I'll put them in group lines of 5 to make counting a little bit easier. Pop, pop, pop. So separate them out. Each little block is 10. So my first throw, I got 123 dice landed colour side up. So 123 dice decayed. And they've been put away into the plastic bag so that I don't use them again. Once a radioactive and unstable nuclei has decayed, it becomes more stable. So it turns into a stable nuclei, and it won't decay again. And those decays we're going to be looking at in a little bit. So this experiment carries on and on. And I'll go writing down throw number 1, 2, 3, 4, 5 until all of my dice have decayed, and we'll then plot that on a graph and we'll take some measurements. So I'm going to be quiet now, and I'll let you guys write down the data from this experiment in the table and plot your graph, please. And you'll see, give thanks that you're not doing this experiment yourselves, because it gets a little bit boring after a while.